direction of the concentric circles? Right hand grip rule. Has to be right hand. If you make the mistake in your exam of putting up the wrong hand, you've just thrown away all your marks. Yeah? Remember, it's the right hand grip rule. What does your thumb represent in the right hand grip rule? Direction of?
Force.
Be more specific.
Field.
The direction. So right hand grip rule. No, not in a straight line. Thumb equals direction of conventional current. And your fingers, your grip. Yes. Direction of magnetic field, or in this case, the concentric circles. Okay? If in the exam it says here's a wire and current, it just says current that way, accept that it's conventional. Because the only time that you would have to actively find out which way is conventional is if they give you a positive and negative. Okay? And then you go, right, let me go from positive to negative. Or they give you a cell or battery, okay, in a circuit. Which one's positive, which one's negative? This one's positive, this is negative, so which way does it go? Clockwise or anti-clockwise? You follow the lines anti-clockwise, positive to negative, yeah? If you want to use the right hand grip rule or the left hand rule. Okay? So if you have a straight wire with current passing through, you will create a magnetic field in concentric circles. How can you, where on the concentric circles is the field the strongest? Closest to the wire. How can you, let's leave it there. If I turn that wire, not into a straight line, but into coils, what do I call this? A solenoid. If I make a solenoid of the single wire, and current goes in this way, comes out this way, what's the shape of the magnetic field produced? Very similar to a bar magnet, passing all the way through the inside of the solenoid. Okay? How do I determine the direction of this magnetic field?
Using your right hand.
Same again, I use the right hand grip rule. However, in this case, what's changed? Thumb is North Pole, and fingers current. Again, conventional. Yeah. So, put your hand on the solenoid, follow the coils or the current in the coils with your right hand and your fingers, and your thumb tells you exactly where the north is, and therefore the south is on the other side. So this one will be south there, north there. And field lines would go, bless you, north to south through the inside. Where is the solenoid the strongest? Inside the solenoid. Why? Why in the inside is this the strongest? All field lines travel in the same direction on the inside, therefore reinforce one another. Where is it the weakest? And why is it the weakest outside? Because field lines overlap in opposite directions, cancelling one another out. Okay? Any questions about the solenoid? What's another name for the solenoid? As in, we use it as an electromagnet. Yeah? So you may see it in an exam described as an electromagnet, and it's just a solenoid. What type of current do we use in this solenoid?
Conventional. AC.
That's what we follow.
DC.
AC.
DC.
Is my magnetic field changing? DC current in a solenoid. Yeah?
It's AC. It's AC.
No. It's just DC.
Yeah.
This will produce a magnetic field that is a constant direction. Okay? So it will always be the same direction, therefore we use DC. You can switch it on and off. The most common use of this is when you're in like a scrapyard with cars, you switch on your electromagnet, huge kind of iron thing connected to wires, and it picks up a car, you move it, and then you just drop it. Yeah? So you need to be able to switch it on and off. If you used a permanent magnet, you'd stick to it and you'd never get it off.
So it's
okay?
a DC?
It's DC. The magnetic field doesn't change. What are the 3 ways to increase the strength of the solenoid field?
More coils, increase current.
More coils / more turns, yes? Increase the current or add iron core. Okay, because an iron core will literally focus the lines inside, making it stronger. Okay? So more coils, increase current or iron core. Is there anything else on 12b? I think that's it. Yeah? Any questions?
Does it increase strength of?
No.
More coils, increase current, iron core. Add an iron core to strengthen the magnetic field.